Okay, today's lesson is lesson 7 on equivalent expressions. We're starting on page 495 with defining a couple of terms. And actually the first word is term. Alright, a term is going to be a part of an algebraic expression. Okay, the next word we need to look at is coefficient. Coefficient is the number factor of a term that contains a variable. A term without a variable is called a constant. And like terms will contain the same variables. Alright, so in the example, I'm going to change the numbers. Alright, we have 3 terms. Each of these are part of the algebraic expression. And for this particular expression, we have 2 like terms. Who can raise their hand and tell me what the constant is? Jay.
A term without a variable.
So in this particular expression, which term is the constant?
8.
Alright, so if it helps, alright, Seth.
What is the coefficient?
They don't have that labeled here. I guess it would have to be for the 2, well, let's see, this would have to be the 2. Because that's the number factor of a term that contains the variable. I'm out of colors. I do purple. So at the real world link at the bottom of page 495, it gives you a word problem that includes an expression. But really all it's asking you is to identify coefficient and terms. So if I have this expression, alright, so question 1 says, what is the coefficient of the term 2x? Who thinks they can raise their hand and give me that answer? What is the coefficient of the term 2x? We kind of already have that same example right here. Seth?
2.
Yeah. And how many terms are in the expression? Jay?
I have a question. I don't understand what coefficient is.
It's just that when you have a number and a variable together, this number is called the coefficient, this is called the variable. It's just another vocabulary word really to give to that part of the term. So how many terms are there in this expression? Each piece is a term. So how many terms do we have? Come on. How many pieces do we have of our expression, Lucas? Four.
4.
Good job.
I understand.
All right, so let's practice with some examples on page 496. We're going to be simplifying algebraic expressions. So we have to take what we learned yesterday and use that before we can actually simplify. So they give us a sample, they give us example 1 that you can follow along. It's 4 times 6x. So they spread it out and said 4 times 6 times x. Okay, and then they moved the parentheses, combined the 4 and the 6. 4 times 6 is 24x. So let's practice a few. All right, so 3 times x times 11. Okay, so we're going to combine 3 times 11. Remember, we've learned properties that say this is okay. All right, and so then 3 times 11 is?
33.
33 times x. We don't have to put the dot. We just put the number right next to the variable. It means multiply. And we're done. All right. How many x's do you see?
3.
Okay. Add them together. That's all you have to do. Done. right, now this one's a little bit different because we have a constant here and then we have two like terms. So the constant will stand alone, but we can combine our like terms. So how many x's total will we have? We have a 7x plus a single x. 7x plus the single x, 7 plus 1 is 8 x's, plus we leave our constant to stand on its own. All we did was combine our like terms, and that's as far as we can go with it. Now, if they told us that x equals something, then we could solve and finish it all out, but they haven't told us that, so we're done. All we did was combine our like terms. Jay?
Do you have to put x after 16?
I don't see a 16.
If you add the answer?
No, we can't add these two together. We don't know what x is. You can't just start combining everything. It just is like this. We don't combine the constant. Those are not like terms. We only are combining like terms. Paige?
I'm saying if you said 16x, if you added them together.
I know, but we don't have 16x because this is just 8 by itself. This tells us that we're going to multiply 8 times an unknown number. It's just like as if these were all numbers. You wouldn't start just adding things together. You have to still follow that order of operations. Seth?
What did you do with the 7?
I combined this 7x with this 1x. Remember, it just because the 1 isn't there, imagine it's a little ghosty sitting in there. So I added 7 plus 1 and got 8. Should we practice with some more of those or move on to the next example? Okay. All right. So on example 2, we've got word problems. So the first word problem tells us about these friends that are going and have to pay this admission to get to a museum. It tells us X is the value of the admission ticket and an extra $1 if they want to go see the mummy exhibit. All right, so it gives us an expression and works us through example 2, but let's look at D. It says to make an expression if it's a total cost of 6 friends going to the museum, but only 4 of those friends want to go to the mummy exhibit. Okay, so if we're going to write down how much it costs to go to the museum plus mummy exhibit. All right, what expression can we write down to show how much it costs to go to the museum plus we want to go to the mummy exhibit? Seth?
Addition? Like the addition song?
Okay, so yeah. What does it say the museum admission is in the word problem? Addie? Well, it says our dollar is going to be something else. Look at the very first line of the paragraph there that's in bold on your page. It says 3 friends will pay, say it, Lamar, X dollars. We don't know. Plus, now how much, Addie, does it cost to go to the mummy? You said it a second ago. $1. Okay, so if I write this, I will say X plus 1. Agreed?
Yeah.
All right. So it tells us we've got 6 friends going, but only 4 want to do both. So if 4 want to do museum plus mummy, how can I write that?
Put a 4 under the X.
No, we're not dividing. Each friend has to pay X plus 1. So that would be multiplication. 4 friends pay for the museum plus the mummy. But it said we had 6 friends that were going. So these other 2 people, they don't want to add the extra $1 to see the mummy. They just want to pay the admission. So how many friends are doing that?
4.
No. 4 friends want everything. 2 are left over. 2. All right, so group 1 went ahead and combined through the distributed property 4 times X plus 4 and then plus 2X, which is great. It's still not simplified yet because we have like terms. All right, so we need to combine these 2 like terms. 4X plus 2X gives us what? There you go. 6X, and then the constant stays by itself. All right, we're going to practice simplifying a few more, and then you'll be able to practice on your own. So over on page 497, problem E asks us to simplify 3X plus 9Y plus 2X. Step 1, find the like terms. Who sees a like term? Brayden, what you see? The what? The 3X and the 2X. Good. If I add 3X and 2X, what do I get?
5X.
And then add the 9Y. Done. Okay. Next. Simplify again. 7 times 3X plus Y. All right, well, first let's use what we learned yesterday. 7 times 3X, what does that give us?
21X.
All right, plus, now we have to say 7 times the Y.
7Y.
There you go, that's it. And then G asks us to do something different. It says to factor. Factor 12x plus 8y. Now this is like what we did yesterday. It just has variables in it. So we have to find the GCF like we did yesterday of 12 and 8. What number, Nadia, should we pull out of these two?
4.
I like 4. All right, so how many times will 4 go into 12?
3.
And how many times will 4 go into 8?
2.
Okay, can I pull anything out of these two?
No.
All right, so 4 is the GCF, so it will stay on the outside. Ready to multiply. Now, here's the only thing you have to remember. So this 12 is X, and the 8 has a Y. And remember from yesterday, we added what was left over on the bottom. So then you have to write 3X plus 2Y. So this is exactly what we did yesterday with just variables added in. Okay, questions? Will pay just admission only. So again, 4 friends want the museum plus mummy, and then the other 2 friends only want to see the museum. So there's our expression, and then it said to please simplify it. All right, so what do we got? All right, Seth.
You could change the 4 and the X out.
What you mean?
Change places with 4 and the X.
Well, we don't just change places.
Is that the
Why? No. Well, it's part of the answer. That's the first part. We wrote an expression, but now we're going to work to simplify it. Why don't I pause the video and we work in our groups to try to figure out how to simplify it?
No.